Right, good afternoon. We're going to go ahead and get started here. We're going to talk about Noble Boiler Service today. Got a short, brief little PowerPoint to touch on some issues. Then we're going to jump into some of the parts that I have right here with me. So we'll go ahead and get started. If you have a question you need to ask, go ahead and throw it into the chat. Make sure we get that answered as we go along here. My name is Rob Ellis with FIA, and today we're going to be talking about basically some service and maintenance on the Lochinvar Noble combination boiler. So first off, Lochinvar's boiler is designed, engineered, and assembled right here in the United States. Certainly a plus for us in the current climate of the country that's going on. There are three sizes to the Combi model, and the numbers in there will also tell you the BTU size. So it's also important if you're talking about parts, things that you might need, knowing what you have. So just a little nomenclature: an NKB is going to be a boiler only, an NKC is going to be a combination unit. The N or an L at the end will let you know what type of gas that boiler is designed around. Important little feature to know right here is the domestic hot water delivery capacity of your unit. 2.6 gallons a minute. Now that on a 110, that's considered at a 77-degree rise. So just keep that in mind. If you have really cold groundwater, that might not get you to that 120-degree water you're looking for. But 2.6, 3.6, 4.8, those are some things. The recommendations I do have, if you're putting a combi unit in to maybe save a later callback in, is put a flow restrictor on the inlet water to the heat exchanger. We'll talk about that when we get to the heat exchanger. Set it for what you're able to deliver. All right. We're going to talk about the heat exchanger. It is a fire tube design, so it does clean a little differently than a water tube. The boiler pump is built into it. The boiler domestic hot water pump is built in to the combi unit. If you have a boiler only model, it does not have a pump built into it. The pump is going to be external. So we're going to look at. And we're going to get into the hydroblock today because that's what really does our domestic hot water production. That's the Noble heat exchanger. Looks very similar to the one I've got up here on the bench. We're going to talk about really how we clean inside of it and what we do in a servicing, but that gives you an idea of what that one looks like right there. The mesh burners of the combi unit. It's a burner we use really throughout many of the boilers within the product line, and we'll talk about cleaning that today. But here's where I want to talk to really in this is the combustion system. So it's a negative regulation combustion system. What does that mean? So negative regulation really means that I am relying on the air movement that my fan pulls across the orifices within my venturi to draw the gas in, make the mixture, and off we go. Awful lot of words there to say the fact that it's the fan suction draws the gas in into the combustion chamber, and off we go. Faster the fan, more gas. Slower the fan, less gas. So that's really what that's doing right there. That's the gas valve that we use right here in our Noble combi, and we also use this in our Noble boiler only. We use it in our WH and our KH. We're going to talk about really making some adjustments on that as well today. So let's get out of the looking at PowerPoint and let's talk about actual parts and pieces that we have right here. So click all the buttons, get to the right spot, hopefully on there. And oh, now you guys get a great big picture of me. It's awesome. So all my parts. So what we want to talk about here, we're going to start with how does this thing go together? How does this work? How do you maintain it? And how do you troubleshoot it? And those kind of work together, especially if we're talking on the combustion side of things. So on the combustion side of things, we talked a little bit about our fan basically draws air in. In fact, this connects here. So when the fan runs, this is my incoming air, comes in through the air intake pipe into the venturi. If I take the venturi apart, I got to make sure I lean toward the right camera. What that shows me is I have a orifice here and I have an orifice there. As I draw the air in through here, Depending on where I am on the fan speed, there's a flapper in here that opens and closes. At times, I'm going to draw just across the bottom orifice. At times, I'm going to draw across the bottom and the top orifice, really depending on how fast we're going. That's going to create the air sucking, because it creates negative pressure, the gas in. Since this inserts right in here, I'm creating that suction within this venturi. That negative pressure is here on the inlet side of the venturi, which at the end of the day connects over to my gas valve. So I create that suction, my gas valve opens, I use the fan to draw through the amount of air, the amount of gas, that I need, dump it in through my orifices of my venturi, into my fan puts it into the burner. Set off a little spark, and hopefully we get flame, and everything's nice and happy right there. So that's how that part of it works. It's how that air fuel mixture goes. Aside from that, in our combustion side, or our ignition side really, we have our igniter, which has a flame sensor built into it. So this is a Noble igniter with it's an igniter combination flame sensor. Our spark cable takes it back to our control board, which has the ignition module on it. We all spark there. Before I get too far ahead, something has to tell this thing to fire. And what's going to do that? Well, that's going to be in the control itself. I get a call for heat. I have a call for domestic hot water. One of those happens, the boiler, the control looks, hey, what's my water temperature right now? What do I need it to be? And then from there, it's going to go off and fire. Okay? So that's how that works. Once we make a determination that, hey, we want to fire, and what we're going to do, what we do from that point in time is we really determine what's the firing rate going to be. So in a Noble, we look at it at two different sides, especially if we're not, well, in any of our boilers, it's just about any lock of our boiler, there's two different sides to the brain, okay? We have the, I'm going to fire for heat, and we have the, I'm going to fire for domestic hot water. Each one of those looks differently at what it's doing. Generally with domestic hot water, we're going to fire at higher temperatures, and we're going to fire at higher firing rates, because we're kind of in a hurry to get there, make sure that we're satisfying the domestic hot water load. So each side of the control is different, and it interprets it differently. But let's talk a little bit about all this stuff that I got right here, what we just talked about. So we're going to go through, and I always hate start with a problem, but it walks me right into cleaning the heat exchanger over here. So combustion system, call for heat. Turn my fan on, run my fan up to where I want to be as far as where my firing rate is. When I get to that point in time, what I do is I open up my gas valve, spark, light. If that doesn't happen, and I have to prove the flame, sorry, if that doesn't happen, let's walk back through where we needed to be. So some of the things that we can run into there are, we're looking for air, fuel, and spark. So usually the first thing I recommend people do, make sure they have fuel. And that's this guy right here. That's this gas valve. So we want to troubleshoot that. The very first thing that we're going to do is there's two sides, two test ports you can see right here. I've got an inlet, and basically I got a positive on this side. I have a negative on the other side. So what I want to do is I want to put my manometer, my gas pressure manometer, on this side right here. And the reason I want to do that is I want to make sure that I have gas and my gas valve opens and I have enough gas. So it's really a couple of questions. Put my manometer out here. For today's conversation, we're going to discuss it as though it's natural gas. The numbers will be natural gas related. So I want to be between 4 and 14 inches natural gas. To put my manometer on here, I've got 8 inches of gas while it's static. My boiler's off. Perfect. I have the appropriate gas pressure. Send my boiler through the ignition cycle. I walk through it, and my 8 inches of gas, when I go to open the gas valve, goes from 8 to 2. I had pressure, but I don't have volume, and that's why I dropped off. That means I don't have enough gas BTUs in my line to supply my boiler with what it needs, and that's why I'm dropping off like that, okay? So if I have that, stop right there. Let's get that corrected. That could be a gas meter hanging up. That could be a regulator hanging up. It could be any of those things. If it's a brand new installation, we might take a quick look at our gas pipe sizing, make sure that we've sized it appropriately and we've done the correct thing. Um, if I'm sitting there at my 8 inches, I open up my gas valve, I do my thing, I go 8 inches to 6 inches. I got pressure, got pretty good volume, keep moving. What happens if I go sitting at 8 inches, tell it to spark, tell it to do its thing, and 8 inches stays 8 inches? Well, now I want to find out why, because that's telling me my gas valve did not open. And so generally, solenoid on the top, let's check that. Easy way to test is put your hand on it, okay? Do I feel it opening? If you don't feel it opening, I got a switch right here. There's an on-off switch actually on there, so you certainly can make sure that that's on. On occasion, we have had them where they're not, where they're actually turned off. That's always sort of a problematic type of scenario. So make sure you turn it on. And they ship from the factory in the off position. Now, the next thing that I might want to check into, let me make sure I get the right end of it here, it's always a challenge, would be the ends of my Molex plug on my gas valve harness. So I do have two separate sides to it, and one side goes down and connects onto my control board. One side connects to my gas valve. We want to check for 24 volts here. And really the way that we check that 24 volts, there she is. Take the pin on your multimeter and reach it in from the back side. The reason we reach in from the back side is if I put it in here, the end of my multimeter is actually larger than the pin diameter, and I can stretch that out. Then when I go to plug it back in, it doesn't work. So what I really want to do is slide it in here from the back, set it there, go through and fire again, make sure I get 24 volts on it. But always check it from the outside of the Molex plug, not the inside. That also allows you to leave it connected. So you're really getting a true test of, do I have enough? So we test that. We've determined we have gas. Gas is coming through. Let's move to our next step kind of in the process. So our next step in the process is, do I have spark? Now, cheating a little bit here, this is the top off a WHB. So difference in a WHB versus a Noble is we add an extra flame sensor in a WH, which we don't in the Noble. But for all intents and purposes, most everything else is the same. So I want to look for spark here when I'm going through that ignition cycle. So if I'm not certain if it's sparking, and every once in a while it's kind of hard to tell from sight glass to here, go ahead and disconnect your igniter from the top. And that's a T20 Torx head screw. So go ahead and remove that. And you can go ahead and let your igniter hang outside the cabinet. There's going to be a green ground wire. That green ground wire has to remain attached. The reason is in our ignition circuit, I'm sending voltage down here and it's jumping back to ground. It's how I get that spark. In a sense, it's almost like I'm creating a short. And let that hang. Now do yourself a favor. Don't hold it here. Chances are if you do, you'll only do that one time. If for some reason you decide, hey, I think I want to do that a second time, you might want to seek professional counseling for that sort of thing. But I'm certainly not gonna judge you, not at all. But if I don't get spark here, disconnect it from there. Now at this point in time, what we're going to do is we need to get to ground. Now, if you think about it, the heat exchangers are just a big chassis ground because we're grounded to everything. Hold it off one of the studs on the heat exchanger there. And what you do is let it spark from here to here. If I'm not getting spark there to there, I didn't get spark here. Let's keep working our way back. And let's get ourselves back to the ignition module. So the ignition module, right here. Okay. So, and in a Noble, this is kind of mounted really in the front. Then my cable's going to come out. What I want to do is disconnect the cable from the ignition module right here. And then what I want to do is spark it again. It will jump to this ground post right here. You won't hurt yourself. You won't damage anything. You will just jump right here to this ground post. And that's really what we want to see you do. If I've got spark here, all right, this is okay. If I don't have spark here, real quick, I just identified I don't have spark. I got a problem in my ignition module. Now I'll tell you that's a pretty infrequent flyer for these boilers, is that ignition module. But on a residential boiler, you get 4 tries for ignition. So if you've really done this right, your very first try for ignition, you're going to determine your gas pressure, volume, and does my gas valve open. Your boiler will go through a post-purge, pre-purge. It will fire again without you doing anything. So when you do that, your second try will be your igniter. Your third try will be your cable. And your fourth try will be that. And at that point in time, one complete cycle through our ignition before we'd lock out, and I did my gas valve, I did my ignition module, I did my cable, and I did my igniter. Now, we've done that. We're going to pause for a minute, and we're going to kind of evaluate what we got. So if my gas was okay, and my ignition module was okay, but maybe I had some issues here, my next step is actually going to be to check this guy out. And we do that again with our meter. And what you're going to do is take your meter at this point in time. I'm going to go to ohms, the resistance. That's that funny looking horseshoe thing. I'm going to get in each end of my ignition cable. Now we have a resistor in here. The purpose of that resistor is really kind of tamping down some electromagnetic interference that we can create inside the boiler with the, or I should say inside the cabinet, between the board and the fan. So we reduce that with this. There's a potential you could have a bad cable. This should be 1,000 ohms. If it's 700, stop, replace this, go to the next thing. If it's 1,000 though, this is okay. But if I didn't get spark here, or I didn't get spark here, I definitely want to look at this cable, and I want to check for that. If it's an open circuit, it's going to be the same thing. And a lot of times that actually kind of creates a weak or intermittent ignition. And so one of the telltales of that could be some occasional flame failure ignitions. All right, so we've gone through that. Let's say all of that was good for us. What are we left to now? So we'll step back to that PowerPoint presentation we had there for a moment. And we're going to talk about that negative regulation gas valve. So my fan, pulling my air through my venturi, drawing my gas in. So right now we're looking at the third leg of the stool, and that's the air side of everything. Now, and before I get too far ahead of myself, one of the things that we do have in here is we got this reference hose on there, and that's actually referencing the true amount of air that's coming through here. This, one side goes to my pressure switch, and the other side goes onto my gas valve. And that's referencing the actual air. Why? Because I'm influencing my gas valve. And I'm going to influence it, especially when you're doing domestic hot water. Over the weekend, it was nice. It was 70 degrees. It was outstanding. And then it's 40 degrees at night. The air weighs a different amount. So as I'm pulling air through my pipe with my gas valve, or sorry, with my fan, the amount of air I'm pulling will change even though the RPM remains the same, just because of air density. And this guy's adjusting my gas valve for that. It's making some little adjustments. So where does that all fit together? So if we've got fuel, we've got spark, we really want to look at our air to gas ratio. We want to look at our air. So if I'm pulling air through here and I'm pushing it out here, if I have a dirty burner, this begins to get dirty, lack of service, something like that, that's going to restrict the air moving through my fan. It's going to change the negative pressure I'm applying to my gas valve. We're going to get some adjustment, but there may get to a point of time where we can't be adjusting anymore, and my air gas mixture gets out of whack. And now we've got to look at getting that back into where it needs to be. Now, assuming when you installed your Noble boiler, you set up your gas valve, you did a combustion analysis, you did everything correctly. Now we want to kind of get a couple of facts. One, how long has this boiler been installed? So if you say to the customer, hey, when did you get the boiler put in? Oh, I put it in 4 years ago. When did you service it? And they give you that look like, what do you mean? I don't have to service it. We're going to probably go right to a service. That's the direction we want to head right then. Let's save a lot of time because it doesn't take a lot of time to service one of these. And let's open it up and service it. Okay. How do I do that? What do I do with my top plate? Put it over here. All right. So this gasket here is for your fan gas valve assembly. Now, if you installed this and you were good to yourself, you probably left yourself a union outside the boiler underneath, and you loosen that union up. You also have another little union nut here. You're going to loosen that as well. Now, I see you there, Carl. You look like you're a pretty good sized guy. So I'm going to recommend like a small adjustable wrench. We don't need to crank on it. It's just a little bit. It's under negative pressure with a gasket. So we tighten it and then we give it that little bit. So we untighten it the same way. Now, once I do that, this guy's going to pivot away. If I left myself a union outside, I loosen it, I pivot my gas valve out of the way, leave your fan on the top of the boiler, take your 10mm nuts off right here. We want to do that like we're changing a spare tire, okay? First, we want to loosen them all just a bit, just in case we have any torsion on this top plate or through that gas pipe. Just give them all just a little bit. And then we take them all off, again, still staying in that pattern. And I'm going to pull this guy out. Now, note of caution. When you pull it out sometimes, especially if it's been there a little bit, this refractory sometimes likes to stick. If it's sticking, take your igniter and flame sensor out. Kind of reach in there a little bit and just hold it down, let it stay, and pull the burner assembly out. You don't want to break it, so just let it hold in place. If you're just comfortable and you want to make that part of your process, take these out before you do it. A great thing to use is get it up a little bit, slide a putty knife in there, and just hold it down, pull the thing out. Now, if you're on a Noble, when you get that apart, this is your gasket that's going to be in there, okay? Majority of the time, you'll be able to reuse this gasket. The exception to that could be the boiler's been in there for 4, 5 years. You know, they don't use an outdoor reset. They run it hot. They cycle it on all the time. And this could get real sticky. But again, that's a good spot to be able to get in there with maybe a putty knife and separate it. A lot of times this, in fact, in this one, it did stay right here, and it's going to stay on the heat exchanger. That's okay. If you're working with, and just want to talk about it a little bit, if you're working with some of the other wall-hung Lochinvar boilers, some of the older 5-to-1 style, you're going to have this guy here. You're going to have this fiber gasket. This is actually the gasket for my boiler, which we're going to be servicing on Friday. But it has a felt gasket. The newer 10-to-1 models, you're going to get that rubber gasket, okay? Should you have one with you? Well, if you are, if you're in central Vermont and you're servicing a boiler on a Friday afternoon at 4:30, definitely have one of these, okay? Otherwise, you're going to bring your customer home with you for the weekend. But like I said, most of the time, you're going to be able to reuse it. Now, once I get it open, and you guys can look down here in the fire tubes. So that's what these are, those openings. So we talk about like the water tube style boilers and we want to scrub those out. We're really concerned and we vacuum it. We do that. We get into the fire tube, it's a little different. If you have some leftover products of combustion in here, that coffee grounds or things like that, which we don't really see a lot, those coffee grounds, but if you do, vacuum them out. Now, let's talk about that for a second. Why don't I see coffee grounds in here? Well, I'm down fired. I create a lot of velocity and turbulence. So what I'm actually doing is I'm pushing all that leftover products of combustion down through my heat exchanger. And here's my flue collector down here at the bottom into this. And right in the center of it, I have a condensate drain. And that products of combustion is coming out through that condensate drain, which I do get some calls and conversation with people. Why is my condensate dirtier in my fire tube boiler than it is in my water tube boiler? And that's exactly why. If I got a floor mount horizontal water tube boiler, I leave all that crap in there, and then I come by, get my soot vac, vacuum it out, and do that thing. In this guy, it's the same stuff, and I'm just launching it through there. It's coming out my condensate. That's why you really see that much dirtier in these and others. But I digress. So get back into here. While I've got that open, if it's dirty and I want to clean it, what I'm going to do, I'll get a look in there. So give you an idea of what that's looking like in there. So this has got a little scaling on it right here around the sides. It's not bad. But what I would do in here is I'm going to spray vinegar and water in here. And again, the vinegar is going to depend on where you're, what territory or what area you're in. You know, you get up where I am in the Merrimack Valley, head over to Market Basket, and you just get some distilled white vinegar, square that in. I see Nick's here. He's down in the highfalutin Rhode Island area. He might want to get some, you know, apple cider vinegar, a little higher end combustion in there. But it doesn't really matter what you do. Spray it in there. The concentrate doesn't matter. When you buy vinegar at a store, it's a 5% solution. You can buy a industrial strength, which gives you about a 25% solution. And this is stainless steel. So, I mean, we cook with vinegar. We put vinegar in our stainless steel sinks. Vinegar is not going to hurt this. Get it in there, get a green scrubby, screen that up a little bit. When you're done, just rinse it out with water. Now, be cautious when doing that. So this is the front side, if you will, of the boiler when it's hanging on the wall. So you know what's mounted right to the front side? Yeah, it's this guy, my control board. So pouring the water on my control board would be an inherently bad idea. So you really want to be careful doing that. You don't need high pressure. You don't need a hose. I have seen some guys use is it the bug sprayers, little pump sprayer, and they get in there and spray out with that. You can use a little, you know, Poland Springs water bottle. Doesn't really matter. If you really want to be efficient, you can maybe a 5-gallon bucket that you put underneath, take the condensate drain off to collect it, and then you're going to pour down through the top, clean everything out down through. So it's pretty simple. That's what's really involved in it. When we're looking around in here, as we look at it, you know, this one's in pretty good shape. Always looking for hot spots, anything like that. You know, we certainly don't want to see any of those. And then we're looking for, you know, any buildup kind of around those openings. If I've got some, I'm going to spend a little extra time scrubbing that out. And that could even be as simple as I might not have to scrub it. I could actually just spray that in a spray bottle. I could really spray that vinegar right on that area. And that's probably going to do a good job of getting that cleared out for me. All right. Once that's done, put it back together. Put your gasket back on. Put your, you know, your top plate assembly. At this point in time, I'd put the top plate assembly back on with the, make sure that I've got the refractory on it. And down we go. Now, I sort of forgot, glossed right over it, but cleaning this guy, right? So before we put it back together, clean your burner. Clean your burner. The only substance to clean it with is compressed air. Now, because it's a residential boiler, you can use nitrogen to clean it. If you have a CO canister, you can use that. Or CO2, sorry, if you got one of those canisters, you can use that. You cannot use refrigerant. Refrigerant contains oil. Please don't clean your burner with refrigerant oil. If you've taken apart, you're going to replace this gasket. Absolutely. This gasket won't be salvageable. That's the hot spot, and that's what that burner area is going to be subject to. So get it all back together. We put it on. Now, once we have it back together, we really want to pressure test it at that point in time. I don't know if my cable here's got that. It does. Perfect. All right. So on these fans, there's 2 wires that connect to them. Now this is a 4-wire Molex plug, and that connects right there. That's my fan speed and modulation cable. It also, when my unit's powered, tells it to be off. Okay? So if I've got my power wire connected here, I got my 120 volts, I have my unit switched on, and I disconnect this cable, I am no longer telling my fan not to run. So when I do that, the fan's going to run, and it's going to run to its full speed. So what you want to do while that's going on, leak detector. And what we're going to want to do is we are going to want to leak detect around where our fan's going to connect. We're going to test around our sight glass, and we're going to test around our screws. Why run it? Why not just fire the unit? Well, if we fire the unit, what happens? It gets hot, and our bubbles are going to dry. So if we do it this way, my bubbles don't dry. Also, if I find I've got a leak, I can continue to work with it without it getting too hot to touch, or without worrying about my bubbles drying up. Okay? How tight should these be? These are 8 foot-pounds of torque. So again, not a lot. I use a very small socket, which I have found works for me, and it's kept me out of trouble all these years. I've never broken one yet. I have to say that because the next one I'm going to do is going to be my own. You guys can all watch me struggle to get this out of the package. There it is. So this is the socket, the size socket that I use for this. It's a 10mm socket, and it really prevents you from overdoing. But again, tighten it down as far as you can by hand. Really get a good start on it, get a good seat on it. Just keeps you from twisting it or doing anything like that sideways. So 10mm here. T20 here. We pull that apart. We're going to have a Phillips head screwdriver on our top plate here to take that up out of the way. We've got our unit apart. Now we're going to tuck it back together. So as we tuck it back together, at this point in time, really what we're looking at is everything fit, everything's good, I have no leaks. Let's go ahead and fire it. When we fire it, this is where we want to do a little combustion analysis. Now we're talking about a Noble. On the Noble and all the current residential models, we have a built-in flue test port right on the top of the unit, right at the exhaust. And that's where we want to take our flue gas analysis. Now, flue gas analysis, it's sometimes a lot of, I want to look at the flame quality. I want to listen to the unit. I want to take a look at my flame signal numbers. And really the last thing I want to do is look at my combustion numbers. And a lot of times we get overly focused on my combustion numbers. There is no rule of thumb, this is your number for every boiler out there. There's a range, and your boiler needs to be within the range. Or sometimes we get a little out of the range, but not too far. And so what we're really kind of doing there is, for those of you guys that are old school oil boiler guys and can set up by eye, we're bringing a little of that into it. So what do I want to do? I want to light my boiler. I shouldn't hear it light. Okay, I should hear my fan, I should hear all that. Might hear my igniter spark, but I shouldn't really hear the flame light off. It should just be a nice quiet, I'm not lit, and then I'm lit. It's really how that should work. Now, once I'm lit, and we're talking specific to residential today, at low fire, this merely glows. So for those of you that, go out and sit on the porch and, or you go to used to go to the restaurant, we don't get to anymore. They've got that outdoor heaters, that's what we're looking for. It should look like that infrared heater, that orange glow. As I ramp up, I'm going to turn a little bluish purple, but I'm still going to have those orange speckles underneath here is what I'm going to have. Whatever my flame pattern, whatever it looks like, I want it consistent all the way around. If I've got dark spots, if I have anything like that, that's an indicator of a dirty burner anytime I've got a dark spot. But that's really what I see. I don't want a flame that's jumping way off of here. This is all just nice and tight to that boiler. Once I establish that it lights good, and the next thing that I'm going to establish is that there's no noise as I'm adjusting. Now what I want to do, and I got that good flame pattern, I want to look at my flame signal. A flame signal is going to be displayed for you on the screen. 10-to-1 turn down boilers, I got a big range of where that could be. As low as 6 at low fire and as high as 16 at high fire. Now, generally, I'm going to be 6 to 10 at low fire and usually somewhere 8 to 16 at the high fire range. We want to look at it at both. If I've got both these, let's do a combustion analysis. Let's take a look. Now, start with your carbon monoxide. What are your carbon monoxide levels? Should be less than 150 parts per million, and even saying that 150 parts per million is high. Now, propane will get closer to that 150 parts per million level, but natural gas are going to be well below it. In fact, on natural gas at low fire, we may be in the single digits. At high fire, we might be 25, we might be up to 80. The vent runs, a lot of stuff takes place, but 150 parts per million, that's stop. We need to figure out why. So if everything's good, light off was good, no noise, good flame pattern, good flame signal, good CO, take your number. And that's really going to be your number. If you hit all of those marks, what's your number? So let's just, we're back in natural gas conversation. Let's just say that my natural gas CO2 at this point in time is 9.6. If I'm 9.6 at high fire, at low fire, I want to be maybe 0.2 below that. So 9.4 is where I would be at low fire. On propane, I'm probably somewhere between 10 and 11% is my combustion. So I might be a 10.7 at high fire, and I might be a 10.5 at low fire. I want to keep them close together. And really the reason for that is, I didn't get this thing set so I can show you guys. There we go. And so it really gets into how the boiler is going to adjust in that ramp from high to low fire. So if I've got a scenario where my high fire is here, and this is, we're just saying this is in my range, okay? And we're calling that the 9.6%. But my low fire is here. You guys see that? 8%, 9.6% is what I've got there. And in those, even though those numbers are okay, when my boiler adjusts, I get a droop. And that droop can look something like this. And that spot in the middle is out of range. Okay? And this shows up as hard starts. This your customers' complaint is going to be my boiler stutters when it starts. I get frequent or infrequent flame failures. It's something along those lines. So that's why we say when you set up, and not caring where your numbers are, as long as they're in that range, that high fire and low fire, when they're closer together, it looks like that when I'm ramping. And I know it's hard to see those numbers, but the numbers aren't as important as getting them close together to prevent that from happening. And that's that droop. That's what we're looking for. And that's why we want them close together. And for years, as manufacturers, they never said check high and low fire. So what did we all do? We went out and we're good technicians. We took high fire. We were right where we wanted to be, and we never went over here. And then we had to go back to chase those flame failure ignitions, to chase those noises, to chase all of that. And how do you find that in the middle? Because a lot of times we're not sitting there ramping it up and down. Know that the further apart these are, the better the chance is that happens. So that's why we want to check that in our combustion. Okay. And I was getting yelled at for moving the Centrotherm banner out of the way. So I have to put it back down. There we go. All right. I think all is right in the world for some people now, but so that's that combustion. Now, what I didn't talk about is how do I adjust combustion? Gas valve has two adjustments on it. I'm actually going to kind of move around here, get you guys a little better view. I like to hide behind the table because sometimes it sort of hides. So we talked about those pressure test ports. Positive pressure here, negative pressure here. Okay, that's where I'm putting my manometer on. Now, when I'm adjusting my gas valve, right here, this is low fire adjustment. There's a 4mm Allen wrench inside of there. And then right over here, this is my high fire adjustment. I got a 2.5mm Allen wrench right here. So I like to, with this gas valve, start with a low fire adjustment, make that first. If everything was way off, that's where I'm gonna start. And then I trim it out with the high fire. Now, if you're chasing a noise complaint with a boiler, find out where that noise is in the combustion. Use your service mode, adjust your gas valve right to that spot in the combustion range, make an adjustment right there, okay? So they say it's at 30%. Let's go to 30%. Let's get right there. You see if, I had to put the sense therm bender back, sorry. But see if we're dropping off there, and let's adjust right there, and let's check our numbers, and let's do that. You can always adjust in the middle, but really important, low fire here, high fire here. And it's not so much as specific a low fire or high fire, but it's most responsive on your analyzer at these spots here. Now, you're dealing with one of these that's way, way out of whack. Somebody's been there just adjusting, something like that. This guy here, so that screw, it generally wants to be pretty close to flush. If it's sticking way out, if it's way in and you can't get that boiler running, that's a spot to start. Hey, let me see what this guy did before me, and let me get it adjusted back, okay? And start there. All right. So back on my side of the table. A couple other things while we're doing a PM that we want to check into, we want to look at. We do want to clean our venturi, okay? And there are two Phillips head screws right here. You take those out and this whole insert is going to pop out. Now, be a little gentle, but you do have to give it a little bit of love sometimes to kind of, there's two O-rings on it that hold it in place. So if you take one of George Carey's TechMark classes, tell me you want a screwdriver, or find your FIA rep, tell me you want a screwdriver, because that's the perfect tool to just slide in there and pop that out. Once you get it out, I want to make sure that these orifices we talked about right here are clear, and that's usually done with an Allen wrench. I'm going to run that through and clean it. The other thing I want to clean, this fitting right here. So this barbed fitting, take that hose off of it, and again, just run an Allen wrench. I think that's a 1.5mm Allen wrench. Just to make sure you clean anything out. It's a brass fitting. I've got some flue gas recirculation. I get a little moisture in there. That could get a little crud on there. I just want to clean it out. That's a good thing to have as part of a PM. And if you're really chasing a weird combustion issue with a boiler that maybe hasn't been taken care of like it should, that's a good spot to check as well. Go ahead and clear that. If that plugs, I'm not adjusting my gas valve. In fact, if it plugs completely, my gas valve doesn't quite open because this guy helps open my gas valve as well. So it's all part of that. All right. So I'm hoping I covered combustion side of this. Let's jump into the domestic hot water side. We've got about 15 minutes left here. I'm going to say that the number one call that I get in dealing with these is on the domestic hot water side. So there's a couple of points that are important when we talk about domestic hot water on the Noble. First of all, you absolutely must positively have a mixing valve on the outlet side of your domestic hot water. The reason is the boiler wants to kind of run, and so it needs a range to run in. If the boiler's got to sit there and hold 120 degrees dead on, it really can't. It likes to be able to ramp up, ramp down to its thing. We want to put that mixing valve on there. The second part of that equation is there's no way the boiler will ever respond fast enough to prevent somebody being scalded if we have a transition from a heat call to a very small domestic hot water call. Figure I got 180 degrees water in here. I get a very small domestic hot water call coming through here. I could really send out some hot water and scald someone. Mixing valve, it's important. They're inexpensive. It's a good piece of insurance to have there, and it helps the boiler run better, and it actually is going to give more indoor comfort by keeping that temperature consistent. Now, how does this guy work? So pretty simple. I'm the heat exchanger on this side, connected into it, big barrel heat exchanger right now. And what I'm going to do is my water coming out of my heat exchanger, my heated water, is going into here. On a typical call for heat, it diverts and goes out to the system. Water comes back from the system out to my boiler. I get a call for domestic, which is triggered right here. My potable water comes in this side. In here, you guys can hear that. That's my switch. It's a magnetic switch, and on top is the sensor of it. So as that raises, when I get that 1/3 of a gallon of water, triggers my domestic hot water call. A couple of things that are in here, filter. So definitely taking a look at that filter. It's part of a PM. It's not a bad thing to make sure that moves, and maybe put a little vinegar solution in there, or whatever you typically use as a coil cleaner in there. And when I say coil cleaner, if you're a air conditioning guy, not that coil cleaner, but whatever you're using to flush on domestic hot water. In the back there, a little hard to see, but right inside of there, there's a second mesh filter. You can remove that right here. Just so you know, both of these pieces are wet. So if you take these out and the water's not turned off, you'll get your weekly shower right then and there, save you a little time later. But that's how that's going to work. So this is triggered. When that happens, my diverting valve diverts, and now the flow of the boiler water is no longer headed out here, but it's diverted in through the heat exchanger and back up to the boiler for my boiler water, while my potable water comes in, crosses path across there, picks up the heat energy, and goes down. What do we want to check here? Well, if you put a set of service valves on it and you want to clean it, flush the heat exchanger every service, certainly not a bad idea. It's not going to harm it, and that can be flushed just with any food grade type of acidic cleanser is what we're looking for. Get the lime and scale and any of that sort of stuff out there. If I'm concerned if it's working right, I've got this little clip here. By removing it, the diverter head comes out. Now, good news is you won't get wet when you take this off, so not to worry about that. If I'm not certain, hold this in your hand, make a domestic hot water call. You'll watch it divert right there. It's a great way to see it. If it doesn't divert, same way we checked that other fitting, we've got a Molex plug here. Let's check for 24 volts right there. Now, to tell you if you actually have a domestic call, two things will happen. One is the red light that's here on the flow sensor will light up. The second thing is you will get an indicator on the display showing it's a steady faucet, spigot looking thing. If it's a flashing spigot, faucet looking thing, the boiler's in what we call domestic hot water preheat. And what it's doing then is it's actually keeping this warm. And when the boiler's off, or there's no call for domestic hot water, it's sitting there all day long. Homeowners at work, it's no different than a cat or a dog. It's lonely, and it wants to run itself during the day and keep warm. But it's doing that so when they get home and they turn the faucet on, I'm not at 60 degrees. I'm at 117 to 135 degrees. Quicker response. If they don't like that, you can turn it off. So it's a selectable feature. But so it will keep itself warm all day, and that'll indicate by that flashing icon, and the boiler will sit there and do that. So red light, icon, diverter valve diverts. Diverter valve doesn't divert. Let's make sure we're getting the 24 volts. And then we just trace that back up through to there's actually a specific board with a relay on it specific to that diverter valve. So pretty simple. If you did have to clean this side of it, first of all, you're going to get wet, but it's, again, pair of channel locks. Just be nice and easy to it, and you can unscrew that and take it out. Just remember, you're going to get wet when you do that. And then if you clean it. Now, if you've got to clean that side, you've got an issue in your boiler water that you certainly want to take care of. Oops. Make sure you line it's easy. I got to tell you, it's easy to line it up when I can look right down through the hole that won't be there when you're taking it apart in the field. Now, if you want to flush this and you did not put a set of service valves, or I'm sure everybody that's on here would put a set of service valves in if they were putting one in, but let's just say somebody before you didn't do it. So what we have is you can take this whole thing off without a whole lot of work. There are 2 screws right here on the front. So there's 2 4mm Allen screws. Take those out. This has got a set of O-rings on it when I pull that out. Now you have the entire brace plate heat exchanger in your hand. Go ahead and dump it in a bucket of, again, whatever you're using, that vinegar solution, that coil cleaner, the flow aid, whatever you like to use. Go ahead and you can flush the entire thing out, and then you just put it right back in. And there is enough room in that cabinet for most of us to get our hands in and pull it out with any great disassembly. All right. So we talked about this guy here. We really got into our combustion side of things and all of that. Let's see if I got anybody have any questions? I'm kind of looking here in the chat. And other than the people who can't see, anybody got any questions? You can go ahead and unmute yourself if you want to and ask away. Carl, you got a question? I'll unmute you there.
I do.
All right, what do you got?
Water coming into the boiler, into the heating side, not on the, well, even on the domestic. Is it recommended to put filters in and check pH and stuff like that?
So 2 questions, but we'll answer them both together. pH, always important. Absolutely.
Okay.
pH and stainless, pH and copper, any of those things are just not friends. So it's at 7.5 to 9 range on your pH. Now,
Okay.
most water that we get, as far as on the potable side, what area are you in, Carl?
Well, I'm outside of Boston, just north and west of Boston.
Okay, so the MWRA water, so they pH balance that. They've done all of that. So usually we don't have to worry about it. For those that are on well water, that's more of a concern.
Yeah.
The boiler side, pH, obviously dropping off because of glycol or any of that sort of stuff. Now, we go to the other side of the equation on that potable water.
Yeah.
So what we want to look for is sand, dirt, any of that sort of stuff in there. Absolutely. Putting a filter on there, they're short money, to put one in. And that's not a bad thing to do. And just, the whole house spun filters. We even on our larger hot water systems, what we're recommending is recirculation filters. So as the water comes back, we're able to pull out of it. And if you think about it, and it's not an issue anymore, but lead in the water was because the water was leaching the lead out of the pipes.
Right.
So if it leaches the lead out of the pipes, it's going to leach other things. Up where I am, so I'm up near the Haverhill area. I'm in Groveland, and we're an EPA Superfund site, so we have outstanding water now because somebody poisoned it at one point in time. So if you want better water in your community, that's the answer, apparently. So
poison it. Okay.
Woburn and Groveland, it's great. Over in Haverhill, they put a lot of zinc in the water. It works great to adhere to the insides of the pipe and kind of prevent some leaks and that sort of stuff. When you have that, you want to try and filter that zinc out because it's going to build up inside of there and scale up your heat exchanger. So hopefully that answers that.
Yeah, thank you.
Okay, good. Anybody else got any questions? All right. And just really in the neck of time. So appreciate you guys taking some time out. Now, the end of the week on Friday, which I always recommend never doing, we're actually going to PM the boiler at my house. Going to do that on Friday. So we're going to do it live. Now, we're going to cheat a little bit, just in full disclosure. I actually have 2 boilers at my house, and mainly because I wanted to game the system, and you can get 2 rebates if you put 2 boilers in. So I put 2 small ones in. What we'll do for Friday is we're going to kind of pre-disassemble. We're going to take all the nuts and bolts off of one. We'll show you everything whole on one of the boilers, and then we're actually going to pull the parts apart while you guys watch, but just so you're not looking at my backside while I'm, taking out nuts and bolts, because that can get tiring pretty quick. We're going to go over how to flush and rinse out the heat exchanger. We're going to discuss cleaning the burner. We're going to put it back together. We're going to pressure test it, and then we're going to do a combustion analysis. And I'll probably adjust it just because you guys are watching. So that'll be on Friday if you want to jump back. It could be entertaining. I'm making my son do it, so we'll see how that goes. All right. So no other questions. And I'll send you out a link with some stuff afterwards, and I'll send the link to sign up for that class if you want to do it. All right.
Good.
All right. So I appreciate you guys all taking the time this afternoon.
Thanks a lot.